I've chosen to look at scenario B, where you've been looking at the addition of fractions and asked people to add 1/2 and 1/3, and the most common answer given was 2/5. So the mathematical concept in this problem is the addition of fractions and understanding the size of fractions as more than simply numbers. So underpinning all of this is the ability to visualize the size of fractions. So in this scenario, the children or the students have mistakenly added both the numerators and the denominators of the two fractions to get the result 2/5. So they've added the 1 from both fractions to get 2, and then they've added the 2 and the 3 of both fractions to get 5. And the reason for this mistake is obviously that these students have been operating on the numbers without their sort of mental references to aid their reasoning. So they've been kind of thinking about these fractions in abstract, as just seeing them as numbers, and then operating and using their knowledge about whole numbers to simply add the numerator and the denominator, because everything that they've been taught up until this point has been the numbers just get bigger if you add them together. So obviously they're thinking that the 1 and the 1 together will be a 2, and then the 2 and the 3 together will be a 5. So the way I would address this problem is I would wind it back to a fundamental understanding of how each of these fractions is demonstrated on a visual scale, so that the students have an understanding that if you add two portions, if you add two different fractions, it's going to be a bigger fraction than either of them put together, and they'd have to understand the size of the 2/5 in that being smaller than half or a third is fundamentally going to be wrong. And once they can get their head around this concept, it will be easier for them to understand how and why the easiest way to manipulate and go about these questions is to find a common denominator, which is what I would then move on to doing and teaching them how to do if they're given two separate fractions. So I would instruct them to be able to quantitatively understand fractions through use of pie charts or sort of like cake diagrams, so if you cut slices of a cake. And so I would show them something similar to this, demonstrating that this is a half and this is a third, and therefore when you put the two of them together, it would have to be something bigger than either of these two, and this is the sort of thing that they would get. And then I would also draw a diagram of something that was 2/5 and show how that fundamentally cannot be the answer, because if you look at it visually, it's smaller than both the half and the third, and if you're adding them, it's your portion of the pie is going to get bigger. And then I would turn to showing them all the equivalents of a half. So though this is just a half in itself, I would split it up and show them that if you divided that into 6 pieces, a half is the same as 3/6, and then showing them a similar thing with the third, that if you split up this pie into 6 pieces, a third would then be 2/6, and then that would move on to demonstrating common denominators and how those are used and will aid in adding unlike fractions. And this will involve the understanding of physical models rather than looking at the fractions solely as numbers, and I think this is the best approach to take. And then I would move on to establishing how half is 3/6 and a third is 2/6, and if you add those together, that would be 5/6 and not 2/5.